These days, anyone with basic military awareness knows that our country's hypersonic weapons technology has created a significant lead over the rest of the world. Compared to our advancements, the hypersonic prototypes from the US and Europe look like roadside toys. Hello everyone. At last month's September 3rd military parade, our armed forces showcased 8 hypersonic missile models: Dongfeng 17, Dongfeng 26, Thunder, Eagle Strike 17, Eagle Strike 20, Eagle Strike 21, Eagle Strike 19, and Longjin 1000. Dongfeng 17, Dongfeng 26, and Eagle Strike 21 are familiar faces, having appeared in previous parades and defense expos. Today, we'll focus on 3 naval hypersonic missiles with distinct designs: YJ-20, YJ-17, YJ-19, and the Longjin 1000, which features a bold and unconventional design concept. These missiles are launched using solid rocket boosters and travel at hypersonic speeds. Notably, the YJ-19 and Long are the first publicly displayed air-breathing hypersonic missiles powered by scramjet engines. This confirms our country's full-spectrum hypersonic capability and reinforces its dominant position in this field. Ever since the DF-17 was unveiled, skeptics have tried to deny that the US has fallen behind in hypersonic technology, offering various counterclaims to maintain the narrative of American superiority. For instance, when the AGM-183A completed its rocket booster test, some commentators rushed to declare that the US had caught up with China's progress. However, in 2023, the new US Air Force Secretary Frank Kendall led the R project, calling it poisoned milk, not due to technical failure, but to shift focus toward air-breathing propulsion systems. This led to a new narrative that the US simply doesn't favor boost-glide hypersonics and is instead prioritizing scramjet-powered systems. Ironically, the US counterpart to China's YJ-19, the HACM project, was supposed to be finalized by the end of 2027, but has reportedly hit major auditing delays and won't meet its original timeline. Although this gave the ARW project a second chance, the back-and-forth restructuring and disbanding of its team may ultimately hinder its research and development progress. When it comes to hypersonic weapons, the debate over who's ahead isn't always black and white. Some argue that the USS long-range hypersonic weapon is the only program truly on track and that it's far ahead of China's comparable systems. But reality paints a different picture. The LRHW, which is often compared to China's Dome-26, has faced repeated test failures. Now, in Q4 of 2025, it's finally gearing up to produce up to 8 live rounds in fiscal year 2026, just half the number China showcased with the Dongfeng 26 during its 2015 military parade. Others have even dusted off Cold War relics like the Pasingta missile, trying to stir confusion and nostalgia. So let's take a step back and address a fundamental question. What exactly is a hypersonic missile? At its core, any aircraft or projectile traveling faster than Mach 5 qualifies as hypersonic. This classification is based purely on speed, not on propulsion type or aerodynamic design. However, to be considered a true hypersonic missile, it must be capable of guided maneuvering at Mach 5 or above within Earth's atmosphere. Otherwise, even traditional ballistic missiles could be labeled hypersonic. China has made significant breakthroughs in overcoming the black barrier, the plasma shield that forms around a warhead during hypersonic flight and blocks communication signals. One solution involves designing the warhead surface with special curves to create uneven plasma distribution. Antennas are then placed in thinner plasma zones to reduce signal interference. Other approaches include using terahertz waves, lasers, and alternative communication methods to penetrate the plasma shell. That said, aerodynamic design still plays a crucial role to achieve wide-range maneuvering at high altitudes, rapid trajectory shifts at low altitudes, adjustable terminal angles, and controlled descent speeds while also accommodating payloads and guidance systems hypersonic missiles must be engineered with. When we talk about long-range maneuverability in missiles, we're referring to 2 key traits: agility and the distance over which they can maneuver. Unlike aircraft, which measure maneuverability by speed, altitude, and heading, missiles use a different metric: normal directional acceleration. The higher the normal acceleration, the tighter the missile's turning radius and the greater its agility. In simplified terms, normal acceleration in the vertical plane is proportional to the lift coefficient. The higher the CL, the greater the acceleration, and the stronger the missile's maneuverability. A missile's maneuvering distance reflects its spatial agility. The greater this distance, the wider its flight path, the more complex its trajectory, and the stronger its ability to penetrate enemy defenses. To simplify, if we ignore gravity and Earth's curvature, maneuvering distance is influenced by the lift-to-drag ratio. The higher this ratio, the farther the missile can maneuver, making it easier to chart evasive routes and bridge air defense systems. That's exactly why we need advanced wave-riding missiles like the YJ-17. Among the Navy's 3 top-tier hypersonic missiles, the YJ-17 is the largest and most intricate. At first glance, it resembles a scaled-down Dome 17 adapted for vertical launch. It features a closed cone wave-riding body and a non-uniform edge passivation design. We've previously covered these two design concepts in detail. Feel free to revisit that video for a deeper dive. Despite its visual similarities and name, the YJ-17's upper surface is notably simpler than the Dome 17's. It has a lower central ridge and smoother transitions with significantly reduced manufacturing complexity and cost. The Dolphin 17 designed for ground-based deployment has stricter requirements for volume, weight, and range. Ground-based air defense systems are generally more capable than shipborne ones, which are limited by size and power. To enhance its terminal speed and breakthrough defenses, the DF-17 even includes a small rocket booster, necessitating a more complex and voluminous design. By contrast, the YJ-17's warhead is lighter, and its range and terminal speed demands are less extreme. If a booster is needed, it can be much smaller. So, it makes sense that the YJ-17's design is simplified to match its internal payload and mission profile. The Dolphin 17's prominent spine isn't just for added volume. It also helps mitigate aerodynamic issues like upper surface cross-flow. Upper surface cross-flow occurs during glide phase flight. The lower surface generates high pressure while the upper surface blocks incoming air flow, creating a low-pressure zone. This phenomenon is similar to wingtip vortices in aircraft but far more intense. It fluctuates unpredictably with changes in the missile's angle of attack, making it a critical factor in design and control. If upper surface cross-flow becomes too intense, it can disrupt the boundary layer, dramatically increasing friction and heat during flight. This degrades missile performance, destabilizes its trajectory, and can even lead to overheating or structural failure. To counter this, designers use a high spine or central ridge on the missile's upper surface. This elevated structure helps block lateral air flow, improving flight safety. However, a taller spine also increases the missile's cross-sectional area, which in turn raises aerodynamic drag. The YJ-17 features a lower central ridge, reducing drag and maximizing the aerodynamic benefits of its wave rider design. This helps extend its range and maneuverability, especially given the constraints of vertical launch systems. To further mitigate cross-flow issues, the YJ-17 incorporates side streaks and advanced flight control systems that help stabilize air flow across the upper surface. That said, the YJ-17's compact design necessary for vertical launch limits its internal volume. As a result, it carries a smaller warhead and has reduced capability against large targets like aircraft carriers or amphibious assault ships.